Hello and welcome. We are looking at reasoning in algebra. Now, in order for me to do this, I want to introduce something called a two-column proof, and you can see examples right here in green and blue. When we do geometry stuff, and we're trying to prove triangles congruent, or prove triangles similar, or prove that something's a parallelogram, or a rhombus, or a trapezoid, or a square, this is a great way to build up some statements and to provide justification for every statement that we make. So a two-column proof will have two columns for statements and reasons. The statements are the claims that we make. The reasons are pretty much the evidence for something that can be made. Say that you are a prosecutor in a trial and you're trying to prove a defendant guilty. Well, with every statement that you make, and therefore he committed the crime, you're going to have some good reasons behind that to make that statement. Now that therefore will be the final concluding statement. So later statements are made to arrive at a conclusion, and that's how the proof is generated. So what we're going to do though is we're going to do this using algebra statements. We'll do geometry things at some other time. In fact, we're going to use some geometry in this, but we're going to do some actual solving for X algebra. And in order to do that, we need to know how to be able to state our reasons. And they might sound a bit technical, but these are things you've always done. You just didn't have a name for them. Now you do. So in terms of solving for X, take a look at some of these properties. These are all called properties of equality. These are valid reasons for which one can mathematically operate, meaning this is how we can do some simplification, this is how we can isolate our variable, and this is how we can finally solve for X. So look at the first four: addition, subtraction, multiplication, and division properties. They're all starting with if you have left and right side balanced and equal. The next statement after that says that then you could either add, subtract, multiply, or divide the same thing on both sides, and you will still have something equal. A plus C equals B plus C if A equals B, etc., etc., etc. Now for division, you can't divide by 0, so making sure that you understand that you cannot divide both sides by 0 to make that happen. The reflexive property kind of sounds like a no-duh statement, A equals A. We'll say in algebra you're going by some statements. Say you have 2x plus 3 equals 3 plus x plus x. Then you combine like terms here and you say 2x plus 3 equals, well, that's 2x plus 3. And you can see what's going on here. If I subtracted 2x from both sides, I get 3 equals 3. You have the same thing on both sides, really. And what you're able to do with that statement is well, you have 3 equals 3. And then your next statement could say that x is all real numbers because of that reason. Stuff like that. That's what the reflexive property is for. The symmetric property is something that I tend to do a lot without speaking about it. Meaning I might be doing an equation like 4 equals x plus 2, and then I say, oh, and then therefore x equals 2. There's a statement in between that I didn't make that said, well, you know, what happened to x? How come x is now on this side? Right? You subtracted. I saw that. I don't know how you got x over there. That's the symmetric property. You can mirror over a statement just like that. Transitive property: if A equals B and B equals C, then A equals C. If I'm the same height as Bob and Bob is the same height as Bill, then I am the same height as Bill. Something like that. It's kind of a substitution, which is the last one here. If A equals B, then B can replace A in any expression. In any situation here that you have, you can use it. Here are a few more. They're not exactly the properties of equality, but there are different things you can see here. Where I'm dividing down the middle, for the first ones right here will be true for addition on the left and multiplication on the right. So for addition, commutative property is true, where A plus B is B plus A. You can switch the order of them, and your sum is still the same. Same with multiplication: A times B equals B times A. Think 3 plus 5 and 5 plus 3, 3 times 5 and 5 times 3. Associative property is where you can change the grouping of which things are added and you will not affect your result, or you can switch the order in which things are multiplied and you will not affect your result as well because everything's being added and multiplied. Notice these are for addition and multiplication. These are not for subtraction and division because that's not necessarily the case for those. I'm going to skip distributive for one moment here to talk about identity property for addition. This says that any number can have 0 added to it and you will maintain that value. And this says that any number can have 1 multiplied to it and you will maintain its value. Likewise, the inverse property of addition, or the additive inverse property, says that there is always an inverse value for which I can add to my number to get 0 and that is negative a, or the opposite of a. And there is always a value for which I can multiply with my number to get 1, where that is the reciprocal of a, which is the multiplicative inverse of a. Going back to the distributive property, if you haven't seen this before, I can take a and multiply it with b and with c, and I will have to add in between. That is distributing. The opposite is called factoring, going from here to there, where a is a common factor of both terms, and what's left in each term is b and c. But the distributive property applies. The last three are for geometry specifically, reflexive, symmetric, and transitive. We saw those three terms over here in this last slide, reflexive, symmetric, transitive. These three are now being used in a different sense, referring to congruent segments and congruent angles. Reflexive property. Now that's going to be used in a different way, and I'm not going to explain it in this video here. It'll be explained in a later geometry video. Symmetric property, same idea. If AB is congruent to CD segments, then segment CD is congruent to segment AB. And if angle A is congruent to angle B, then angle B is congruent to angle A. And transitive property, same old, just like the other ones with equations. I'll go ahead and move on from there to do some examples for you. Okay, the first example that you're going to see is completely filled out for you, and this one is actually very, very, very detailed, something which I am not even going to do myself when I start to do some other ones with you. Okay, example number 1, solve for x and justify each step with a reason. So over on the left side are the statements, and this is all just algebra. The first one is given. It says, here's the problem. Not the problem. Here's the equation for which something is true. 3 times the quantity x minus 2 plus 5x equals 9x minus 24. Now that is given. So there are going to be a lot of times where they give you something and you can make your first statement with that and say it's given. After that, you can do some building upon your previous statements. Meaning my next statements will be made as a result of having what I had before. First one I do is distributive property. I multiply 3 with x and with negative 2, and I get 3 times x minus 6. Everything I keep the same. So the red is what's changing. Next, I reorder the 5x and the negative 6. So 5x goes first, negative 6 goes next. That's the commutative property of addition. And you might be saying, well, that's subtraction. Well, what I'm doing is I'm adding a and b, and I'm switching them to become b and a. A before was negative 6. Now a over here, negative 6, changed. And I'm adding 5x and negative 6 together. It looks like subtraction, but the value of this was negative. So it's not commutative property of subtraction. It is still addition. Now I combined like terms. I'm going to be using the term simplify more when I refer to these two merging into one. After that, I have to find a way to start isolating my x variable. So what I did for this one was I wanted to keep my x value positive to begin with, so I subtracted 8x from both sides, and you can see that in red. That's the subtraction property of equality right there taking place. Now, on the left side here, I have 8x plus negative 8x being combined, and those are additive inverses. So right here you have the additive inverse property taking place to give you 0. Again, it's kind of a bonus step, something I'm not going to show very often. Probably won't show it after this. And here on the right side, I'm combining like terms, 9x and 8x to get 1x. Okay, 0 minus 6 is negative 6. Okay, that is the additive identity property. Basically, you add negative 6 to 0, you keep negative 6. Okay, and now I'm going to start isolating x a little bit more. I'm going to add 24 to both sides of my equation. That's the addition property of equality. Then this next step is basically addition. Negative 6 plus 24 is 18. Negative 24 plus 24 is 0. Once again, the additive inverse property taking place. These are additive inverses. You get 0 out. X plus 0 is just x, the additive identity property. And I don't want to say 18 equals x, so I'd like to say x equals 18. That is symmetric property taking place. 11 steps. A lot of them kind of aren't really needed for these proofs, at least in the sense that, look, I'm getting a little too detailed. Right? I can will it down a little bit more than that. I don't necessarily need to do all of those things. I just wanted to show you where some of these take place if you choose to use them. So that's one example, and that's already spelled out for you. Let's do another example. This one's going to be a little bit more geometry based, and we have to write in some things this time based on the steps that they give us. Okay, we're going to have to justify each step here, starting with what's been given to us. And here it says that B is the midpoint of segment AC, which means that segments AB and segments BC are congruent. Now, I didn't actually write that step. I didn't actually write this. I could have, but I can build upon that and lead on to the next step. If two segments are congruent, then their lengths are equal. And this step says length AB is equal to length BC. And I only knew that because of the definition of a midpoint. Okay, so once again, this is one of those things where it's like, I'm not sure what reason I needed to write for that before. Sometimes you can kind of just explain them. If you don't actually know the jargon and the vocabulary, that's okay. But you do need to understand what some things mean. How could you arrive at that statement before knowing something about midpoints, right? After that, what I do is I take AB and I substitute 5x plus 6. And then I take BC and I substitute 2x plus 21. That's substitution. You could write substitution property of equality. Again, I'm not going to get too fancy with it. I'd like to do just little by little. Now, after that, it looks like I'm subtracting this 2x from both sides here. Again, you don't have to write these little things, but I'm going to do that for you to help you out. And here you're getting 0. And again, I'm not saying additive inverses here. I just want to say that I'm subtracting, right? This subtraction that's taking place. Subtraction property of equality, actually. 5x minus 2x gives you 3x. And I'm going to do it one more time when I subtract 6 from both sides. That, once again, is subtraction property of equality. Okay, and then the last one is I'm dividing by 3 on both sides. And I get my final answer, which is my conclusive statement that x equals 5, and that was the division property of equality. And again, I'm not going to write out the entire thing. I'll say it out loud. Hopefully you have some abbreviations or whatever else that'll help you out, and I think that'll really be good enough. You need to make sure that you're convincing yourself in understanding what it is you're doing each step, and you have enough steps to verify that you're building a conclusion based on that. Okay, I only have 2 more steps, 2 more examples for you. They're both based on the same thing, and they're 2 different ways to solve for x. This is a little bit more geometry, perhaps, so refer to the graph and info below to try and solve for x in 2 different ways. So there's one way that I'm going to do with you that's already set up, and then I'll make sure to give you the steps with it. I have 3 angles, which when you add them all up, you get 180 degrees, so you have a straight angle there. Now, angle WYT, or angle 1, is 3 times x minus 2 degrees, the quantity. Angle 2 here, 58 degrees, is angle TYV. And angle VYZ, angle 3, is 2x minus 12 degrees. You also have this information here. Angle WYV is 5x degrees. So that is this guy right here, WYV, 5x degrees. And then you have angle TYZ, which is 4x minus 6. So TYZ, 4x minus 6 degrees. So as you can see, there's something that I could probably use when it comes to adding up a couple of angles to equal the other one. Such as right here. This is going to be a given statement. Angle WYV is the addition of measure of angle 1 and measure of angle 2. I think you can see that, although this also, in a way, is the angle addition postulate. I'm adding this angle with this angle, and I get the entire angle. Okay, now 5x equals 3 times the quantity x minus 2 plus 58. Now, how did they come up with that? Well, as you can see, this is measure of angle WYV. That is 5x. That's a substitution. Measure of angle 1, yep, that applies. And angle 2, it's right there in that quantity. This was a substitution step. Clearly, it was. The next one, it looks like I'm good. There's distribution. 3 times x, 3 times negative 2 gives you 3x minus 6. So distributive property. I'll say distribution. Okay, next, combining some like terms here, negative 6 and 58. It's really addition. I'm just going to say simplify, simplification. Okay. Now I'm going to start isolating that x variable. Let's subtract 3x from both sides. Yes, that term was subtraction. And I have isolated my x term. Now to isolate my x variable, I'm going to divide both sides by 2. And you'll get x equals 26. And those are the steps. Look, I'm not writing these big fancy terms. I probably should be, but for the sake of room and time, I'm going to leave it as is. Okay, let's find a different way to solve for x. Now, there are a few other things that we know about this thing, such as, look, this measure of angle TYZ is 4x minus 6. So another way of writing this whole angle right here is 4x minus 6 degrees. So why don't we make a statement where I'm adding this angle, TYV, with this angle, VYZ, or 2 and 3, and I get the measure of angle TYZ. So let me write that statement out. I'm going to write the statement that the measure of angle TYZ, besides the fact that it's 4x minus 6, we know that that's given. I'm going to save you a little bit of time. That's the measure of angle 2 plus the measure of angle 3. Okay, now that there is not given to us. In this case, they gave us this. This one's not given. This one's using the angle addition postulate. And what that postulate says, once again, is that you can add two smaller angles and come up with the measure of the larger angle. As long as they are adjacent to one another, you add those two together, you get the sum of the larger thing. So what do we use with that information? Well, now we're going to use some substitution here. I'm going to substitute 4x minus 6 in for TYZ. Angle 2 is 58 degrees. And then 2x minus 12 is measure of angle 3, or at least in degrees. And again, that was a substitution. In a way, when you're doing these steps, you're actually thinking of the reason before you make your statement. But if you're telling somebody else, sometimes you want to tell them the statement and then say, this is why. Even like when I teach something. I don't say why something is and then teach it. I teach it and then I give the reason why. Okay, so it looks like there's some combining like terms that I just want to do here. So again, because it's each individual step, you want to do them one at a time. I could do something like commutative property and say that I could switch negative 12 with 2x, but for the sake of time, I just want to subtract 58 or 12 from 58. So I have 4x minus 6 equals 2x. 58 minus 12 is 46, and that was some simplification. And by simplify, what I mean is that I'm dividing this equal sign here with this expression and this expression. And what I'm doing is I'm not moving parts over to the other side of the equation, so to speak, right now. Rather, I am cleaning up one side, like the right side, or the left side, or both sides. That's the simplification process, at least in my eyes. Okay, from there, step number 4, let's go ahead and start moving over our x's. I'm going to subtract 2x from both sides. You can see it's a subtraction step. 2x minus 6 equals 46. Okay, move that 6 over. That's addition now. I have to add 6 to both sides. So that's 2x equals 52. And as you can tell, this is going to have to be division. X equals 26. Division. And it's the same x equals 26 answer as we got before. So not much different. It's not math you haven't done before, especially if you've been watching any of my other videos, then you know things about the substitution and angle addition postulate and everything like that. However, you're really given those reasons, and now you have a good word bank or term bank for different ways that you can actually use some of these terms, and you have formulas behind them or whatever else, just examples of what they have there. So those are good, and there are a couple other ones as well. For instance, one that I used that I didn't say before, 2 of them. One was definition of midpoint, and another was simplify or simplification. Fiend.